All right, everyone. So as per usual, right before a test, I know everyone is a fan of me making these videos where I go over the test review in detail, and you can go back and rewind and watch this video as many times as you have to ensure that you are ready. Will some of you watch it and not? Yes, a lot of you will. Some of you won't, and then it reflects on your test grade. But anyways, so for the first question over here, it says find each arc measure. And this is pretty simple. You just have to remember that all of the degrees inside of a circle is equal to 360 degrees, and you can use that property. And you're going to use like some of the properties of like a straight line equals 180. You know that this little box represents 90, so on and so forth. So let's answer the first part of the question. It says, to figure out the measure of arc CD, well, I know that CD is attached to this angle right here, or that central angle. Right? So if I can figure out what the measure of that angle is, and that tells me what the measure of arc CD is. And if I know that this entire thing is 90, well, to get this missing piece, I do 90 minus 53. And I don't really need a calculator for that, but I can do 90 minus 53, and that's equal to 37 degrees. All right. The next question is saying find the measure of arc AB. Well, the other property we should probably remember is that if I look at a straight line, I know that this whole thing right there is equal to 180 degrees. Well, I already have two pieces of that 180 degrees. So to find the missing piece, I can just subtract those two from 180. So I'll do 180 minus 53 minus 79. And you know that AB is equal to 48 degrees. All right. So now if I want to know the measure of ED, again, I'm going to use the same property. So I already established that this one was 37 degrees. I'm going to use the same property about the straight line being 180, but except on this side now. So if I know that this entire arc over here is 180 minus the 37 gives me this piece right there. So I'll do 180 minus 37, and that gives me 143 degrees. This is all pretty simple. And again, you just have to remember that whatever the central angle is equal to, that's the same measure as the arc length, or not the arc length, but the arc measure in degrees of that's connected to that central angle. So then if I look at EB, well, didn't I already establish that AB was 48 degrees?
Teachers at this time, please release students with pink senior ACT passes. Once more, please release students with pink senior ACT passes. Students, read your passes carefully. It should say to report to room 119. Thank you.
It's not like they already announced that, but anyways. So if I wanted to know the measure of arc EB now, again, EB is both of these arcs connected. So I'm going to add 79 and 48. 79 plus 48 is equal to 127. And then for arc BDE, so to go from to figure out the measure of this arc from B to D to E, I'm going to add together these three angles because that's what makes up that arc. So 53 plus 37, we already know that that was 90. 90 plus 143 gives us 233 degrees for that one. And then for arc DEC, so let me do a different color for this one. So to get from D to E all the way around to C. So you can do this one of two ways. You can either add up all of the angles that make up this entire arc, or you can also recognize that an entire circle is 360 degrees. So if I just want the measure of this arc right here, I could just subtract that piece that's 37. So I could do 360 minus 37, and that gives me 323 degrees for part F. All right, so not so bad. All right, so if I look at example number 2, now I'm going to use some algebra with that concept of central angles. So here I know that this arc right here is connected to the expression 6x plus 33. So one of the properties that you need to remember about just angles in general is that this angle is the same as this one, right? Because of vertical angles. It makes a perfect X right there. So these opposite angles are the same. So really, I would need to know what the measure of this angle is right there. Well, luckily, I know that a straight line equals 180 degrees. So from here to here, we know that that's 180. So if I have those two angles right here, the missing angle would be 180 minus those two angles. So I could do 180 minus 45 minus 28. And that gives me 107 degrees right there. Right? So then that means that the measure of these two angles right there is 107 plus 28, which is 135. Granted, you could have also just subtracted 180 from 45 to get that angle, but I wanted to show you the how to find that missing piece too. So I know that this expression is this angle, and this angle is the same as 135. So I'm going to set those equal to each other. So when I do that, I get 6x plus 33 is equal to 135. So now from here, it's just basic algebra. I subtract 33 from both sides. I get 6x is equal to 102. Yeah. So then 102 divided by 6 gives me x equals 17. All right. On to these questions. So here, what you want to figure out is arc length. Hopefully you remember the formula that the arc length is equal to whatever measure of arc you're looking at divided by 360, and essentially all of this times the circumference of the circle, which hopefully we remember is 2 pi r, right? I'm going to make a little note of that. This is the circumference, if I have space to write it. That's fine. All right, so that's the circumference of a circle. All right, well, luckily they already gave us the radius over here is 15, so I'm just going to put r is equal to 15 just to remind me. And the first thing they want you to do, I probably should have flip-flopped these around. Let me do number 4 first. If I want to know what is the arc length for VW, well, VW, I need to figure out what is the measure of that arc first. So in order to do that, I need to know what the measure of this central angle is. So I know that I have 90 degrees right there. This is a straight line. So to figure out the measure of that arc right there or that angle, I have to subtract 180 from those two. Let me do that real quickly. I know I have 180 minus 90 minus 26, and that's equal to 64. So I know that this right here is 64 degrees. So once I have the arc measure, once I have the radius, that's pretty much all I need for all of this. So VW is going to be, so the measure of arc VW is equal to our angle measure 64. So 64 divided by 360 degrees, right? Times 2 times pi times, and then our radius is 15. Okay. Now, some of you, now I know some teachers require you to actually simplify this, like in a more simplified fraction. I'll show you how to do that. But for me in my class, personally, Mr. Louis' class, I'm okay with you guys just giving me the decimal. But let me show you the simplified version first. So I know that if I have 64 times 2 times 15, and I'm going to leave it in terms of phi, I'm going to have, let's do 64 times 2 times 15. That gives me 1920 pi over 360. Right? So now if I divide that out by 360, I'm going to have some decimal. And typically they wouldn't want that on the FSA. What they would want you to do is write this in fraction form. So what you can do is you can press second and this little arrow button, and that converts it from a fraction or from a decimal to a fraction or vice versa. Now, most of the time you're not going to use a mixed number. In order to convert this back into an improper fraction, we're going to press second and then the ABC, second ABC, and that gives you 16 pi over 3. All right. Now, granted, I mean, in my class, I'm okay if you just multiply this all out. So I get 64 divided by 360. You can multiply that by 2, multiply that by pi, either 3.14 or the pi button. I'll just multiply by 3.14. And then multiply that by 15. And I'll give you 2 decimal places as the answer. So it'll be 16.75. All right. So then if I want to know the arc length for UXV, well, let's see. UXV, there's U, and then X is all the way around here, and then V is all the way around there. All right. So let's see. I know, first of all, I think it might be helpful to know what the measure of UV is. Right? So I know that UV is, we have vertical angles here. I know that this angle is the same as that angle. And if this arc measure is 26, and so is that one. So if I want to know what is the actual angle measure of UXV, right? Or arc measure, I should say, I can do 360 minus 26. So that gives me, so I know that X over here is equal to 334. So now when I plug that into my formula for arc length, I know that the arc length, I should say arc length of UXV, well, that's equal to our arc measure, so 334 divided by 360. All of this times 2 times pi times our radius of 15, right? So I'm just going to go ahead and give you the decimal version. I think if you want to write this out in fraction form, I'll provide that answer for you here on the side. So I'll do 334 divided by 360 times 2 times 3.14 times 15. And that gives me 87.40. Right? Now, if I did the fraction form, I'll do 334 times 2 times 15, all in the numerator. 10020 pi over 360 divided by 360. I'll give you the improper fraction, second arrow, second ABC. And that also gives you 167 pi over 6. For those teachers who want the pi version simplified. All right. So moving along, if I go to number 5, okay, so one thing that stands out to me here is that I have 2 chords here, right? And these little tick marks are indicating that the distance from the center to those chords, or the perpendicular distance, I should say, between the center and those chords are the same. So again, you just have to recognize that if that distance is the same, then the chords are the same, and their corresponding arcs are also the same. All right. So make sure you keep that in mind. So they tell you right here that DC is 12x plus 7, and that CB, so CB is 18x minus 23. So I pretty much already established this, that if we have the perpendicular distance from the center to the chord are the same for both of the chords, then the chords are the same, the arcs are the same. So we can really just set this equal to each other. So I have 12x plus 7 is equal to 18x minus 23. I'll go ahead and do all the math. I have minus 12x on both sides. Might as well at the same time move the 23 over there, save some space. So these cancel, these cancel. I'm left with 30 is equal to 6x. And then when I divide by 6, I get x is equal to 5, right? Granted, they're not asking for the value of x, they're asking for the measure of DAB. So now I just got to go ahead and, that's not as straightforward. I know that with x equals 5, I can plug it into those two. So let me plug it into this one and see what happens. If I plug in 5 into that, I'll get 60 plus 7. So I have 67 degrees. And if I know that this angle, this arc is the same as that arc, then they're both 67 degrees. So that gives me the angle measure, or the arc measure of these two right there, but that's not the one that they're looking for. What they really want to know is this one right here, right? The one that I have there in red. So again, you know that an entire circle is 360 degrees. So if I subtract those two angles from 360, that pretty much gives me my answer. So 360 minus 67 minus another 67 would give me 226. So the measure of DAB, or of arc DAB, is equal to 226 degrees. Please try not to mess that up on the test, and make sure you read the directions carefully. All right. So now for number 6, now we're going to get into some tangent properties. When I look at this problem, well, let's see. They went ahead and they were nice enough to tell us that DE and EF, though these two lines are both tangent to that circle, right? So one of the properties about tangents that you have to remember is that if there is an external point out there and the two tangent lines intersect outside there, then this side is the same as that side. And now this is just a simple algebra problem. We have 10x minus 19 is equal to 4x plus 23. So if I want to solve for x, I'm just going to go ahead and subtract 4x from both sides. At the same time, I'll add 19 to both sides. And let's see, I'm left with 6x is equal to, God, my mental math is not at its finest right now, 42, right? I'll divide both sides by 6 to get x equals 7. And again, make sure you read the directions. It doesn't say what is x, it's asking for EF. And it doesn't matter which one you plug it in, they're both the same, but whatever, I'll just be consistent with the question. EF is equal to 10x minus 19, which we now know that x is 7. So 10x minus 19 is equal to 70 minus 19, which is 51. Hope I'm doing my math right there. All right. Moving along. I hope I'm not rushing through this, but I mean, I guess this is the video, so you can actually just go back and rewind it, right? So anyways, for this one, it says find the perimeter of PQR. So hopefully you remember that the perimeter is the sum of all the sides of a figure. Right, I'll just leave it like that, sum of all the sides. And kind of like what I established here earlier, if I have two tangent lines, and you can clearly see that these are all tangent lines around the circle, right? But if I have two tangent lines that meet at some point outside of that or away from the circle, then those two sides are the same. And it's no different for this one. If I zoomed in a little bit on this, then I can easily see that here I have a tangent line, here I have a tangent line that meet at some point or external point out there. So that means that this is the same as that, and if that's 12.2, then that side is 12.2, right? I can do the same thing over here. I know that if this side is 5.9, then this side over here is also 5.9. Now, this isn't as straightforward because they didn't give you either of these two sides, but if they gave you the entire length of PQ is 27.4, then you can go ahead and subtract 27.4 from 5.9, and that gives us this little piece right there. So I don't feel like subtracting decimals in my head, so I'll do 27.4 minus 5.9, and that gives me this this little side to be 21.5. So if this is 21.5, this is 21.5, right? And now I have pretty much all the pieces of all the sides of this triangle PQR. So I just add them all up. So I have basically 5.92 times 5.9 plus 5.9 plus 12.2 two times 12.2 plus 12.2 plus 21.5 two times plus 21.5 plus 21.5. And I get my perimeter to equal 79.2. Sorry, I realized that was outside of the window. All right. And now, of course, there is a back page to this because there's plenty of circles to be learned. If I look at number 8, all right, I have more tangent line properties. So the other property you have to remember about tangent lines is that if I were to connect my radius to that point of tangency of my tangent line, hopefully you guys remember that the angle that forms there is a right angle. And of course, we can do a lot of things with right triangles. That's one of the things we learned the most. Is now if I want to figure out what this missing side of the triangle is, right? I have to all I have to remember to do is, got blurry there for a second, but all I have to remember to do is the Pythagorean theorem: a squared plus b squared equals c squared. Why that's getting blurry? You go out and then get blurry. Whatever. Focus. Okay. So granted, we have two sides of this triangle, but this is the side that we're missing. Now, the part that I imagine most of you would forget to do on the actual test is most of you are going to look at this and be like, oh, well, I know that the entire length of my hypotenuse is 11, right? That's not the case. 11 is only the piece from here to there, right? Unless they have like, and this is why I included this problem, unless they have like these little, like, kind of, they're not arrows, but this these lines indicating that this is the entire distance of the hypotenuse. You can't just assume that. Yeah, the bar, whatever you want to call it. So here they don't have that for you. So you just have to assume that the 11 is only corresponds to the side length from the circle to that outside point. So hopefully remember that the center of a radius is the same no matter where you are. No, I didn't mean to say that, that the radius of a circle is the same wherever you are. So if this right here is 8, then this right here is also 8, which means that the entire length of that hypotenuse is 19. So now I have all the pieces that I need for a squared plus b squared equals c squared, and I just will plug it in. So it doesn't matter whether 8 or x is a or b. I'll just do x as a. So x squared plus 8 squared is equal to my hypotenuse squared. Right, so now I have x squared plus 64 is equal to, and I wish I knew all my squares, but whatever. I'm human. So that's equal to 361. Subtract 64 from both sides. X squared is equal to minus 64 is equal to 297. So hopefully you guys know that in order to get rid of a square, use square root both sides. So then x is equal to whatever the square root of this is, which is 17 point. And I'll just stick to 2 decimal places, 23. All right. So same thing over here. Well, I have my hypotenuse, and I know that the entire length of the hypotenuse is x, so no tricks there. Well, one little trick. I know that this entire length is 3.2, but this entire length is not 3. It's only 3. It represents only half of this length of the triangle. So this is 3, but again, like I established earlier, the radius is the same no matter where you're looking, right? So if this is 3, then that means that this side is also 3, and the whole length is actually 6 instead. Please be mindful of that on the test and look out for that. So now I have everything I need. I know that 3.2 squared is equal to, not equal, plus 6 squared is equal to, all of that is the hypotenuse squared, because that's opposite of the 90-degree angle. So now I have, I'll just do the math. 3.2 squared is 10.24 plus, I know that that's 36. And then plus 36 is 46.24 equals x squared. And now to get x by itself, I take the square root of both sides. So x is equal to, why did I erase that? So 46.24 square root is 6.8. All right, so this question over here is a handful. It says that GP is equal to PH. So GP is equal to PH, right? So hopefully this figure kind of looks familiar to you, because here we have 2 different chords. And now this right here is indicating that the distance from the center to my chords, or both of my chords, is the same. That means that this chord is the same as that chord, and their connected arcs are the same to each other as well. So let's just kind of keep that in mind. Let's see what other information they gave you. They say that GA, this right here, is 17. It's a 17. ED, the arc ED, so this little arc right here is 37. They also tell you that AB is 87. And then they want you to find the measure of each of these things. So, all right, there's a lot we can work with here. So the first thing they want you to know is, what is the measure of DB? So I know they want you to know, what is this entire measure right there? Well, I know that this entire measure is the same as this entire measure. And if I know that this is the perpendicular distance, I know that this side is the same as that side. So if that's 17, then this is 17. And if this entire thing is 2 times 17, 34, then this whole thing is 34. All right, hopefully I didn't go too fast there, but it's just all those properties about chords that you have to remember. The other thing they want you to know is EG. Well, I kind of already found that, 17. All right, and then they want you to know, what is the measure of arc DB? So DB, so this arc, let me use a different color. So this arc right there, well, let's see. I know that this arc is the same as this arc over here. Now, we don't have any information about those 2 arcs specifically, but I do have the measure of the arcs that are, I don't want to say complement of that, but I know that we know that the whole circle is equal to 360. So if I subtracted these 2 angles from 360, minus 87 minus 37, then I get 236 that's shared between these 2 arcs. And if these 2 arcs are the same, I could just divide this by 2, and that gives me the measure of each one separately. So I know that this whole arc is 118, and that whole arc is 118. So that means that DB is 118 degrees. All right, so now I want to know FA. And again, the perpendicular distance from the radius to, that cuts through the chord and touches the arc, that means that these 2 are going to be, these 2 arcs are going to be the same. So FA is just going to be half of 118. I'll just divide that by 2, and I get 59 degrees. And then DC, well, it's the same case over here, 59 degrees. All right, I don't even know how long that video ended up being, but hopefully all of that made sense. If it didn't make sense, the beauty of these videos is you can rewind it and rewatch it as many times as you have to in order for it to make sense. So if you have any questions, of course, feel free to ask me whatever you want, and good luck on the test whenever you take it. Bye. How do I stop recording? This is all going in there because I am not going to edit this. Come on. Stop.